Hello everyone, welcome to TMT Tips with Taylor Mobile Tutoring. My name is Donia. Today we're actually covering a topic that was requested by one of our Instagram followers, which is solving and graphing inequalities. So here we have a couple inequality examples that I'll be covering with you guys. First and foremost, the only difference between an inequality and an equation is the fact that these have a greater than or less than or greater than or equal to, less than or equal to sign instead of an equal sign. What an equation is telling us is x equals 1. That's the only solution to that equation. Inequalities are telling us that our solution can be any number that is less than 6. So it's telling us that the solution for the inequality, in order to make this true, would be any number that's less than this number, greater than this number, less than or equal to this number, greater than or equal to this number. So let's dive right in. So here I have an example. This inequality is x plus 9 is less than 15. My goal, just like with a regular equation, is to isolate my variable so that I can figure out what my solution is. So since this 9 is being added, I'm going to do the opposite operation in order to remove it from this side of the inequality. So I'm going to subtract 9 from both sides. This cancels out and becomes 0, so that's gone. Next I have 15 minus 9, which gives me 6. I bring down my x, and now I have x is less than 6. That's the solution to my inequality. In order to graph this inequality, I would put it on a number line. This open circle represents a greater than sign instead of a greater than or equal to sign, which would be represented by a closed circle. And this is showing me that the solution to this inequality, in order to make this true, my solution is any number that is less than 6. So here I have my open circle pointing to the left to show that my solutions are any number that is less than 6. In my next example, we have d minus 3 is greater than or equal to 6. Just like the first inequality, I need to isolate my variable. So I'm going to add 3 to both sides for this one because here it's being subtracted, so I'm going to do the opposite operation. Once I add 3 to this becomes 0 and it disappears. When I add 3 to the other side of my inequality, I get 9. I bring down my d, and now I have d is greater than or equal to 9. Again, I'm going to be plotting this on a number line, and this is telling me that solutions to this inequality are 9 or anything greater than 9. So I have a closed circle to represent that 9 is a solution to this inequality, as well as all other numbers that are greater than 9. This last example shows one situation in which our sign would actually be switched in our inequality. So to begin the inequality, I have negative 2x plus 4 is greater than 6. First thing first, just like we did on the previous two examples, we're going to subtract 4 on both sides because it's being added. We're going to do the opposite operation. This 4 disappears. I subtract 4 from 6, which gives me 2. I bring down my negative 2x. Now, this negative 2 is being multiplied by this x. So I need to do the opposite operation, which is division, in order to cancel it out. So I'm going to divide by negative 2 on both sides, but since I'm dividing by a negative number on both sides of the inequality, my sign is actually going to switch. So even though we began with a greater than sign, since I'm dividing by a negative number, we're going to end with a less than sign. Negative 2 divided by positive 2 is negative 1, so my solution is x is less than negative 1. Plotting this graphing this inequality on a number line would be exactly the same. So I have an open circle on this negative 1 to show that's not a solution. My solution is any number that is less than negative 1. I really hope that helped you guys out. Please make sure that you follow us on Instagram at Taylor Mobile Tutoring, as well as subscribe to our YouTube channel. We'll be posting new videos every day. Thanks.